Hi everyone, in this session we are going to review for exam 1, and I've made a document. You should be able to see it in the share files, so you can download it and follow along with me. So first I will share my screen with you, and we're going to work through the problems that I have here. Okay. So researchers wanted to gather data on how many people check their phones between 10 and 14 times an hour. Their data is below. So here we have their number of times that they check their phone in an hour and the frequency. Let's go ahead and just begin by calculating our relative frequency, and I'm going to just pull up our TI-83 here. So the first thing we'll have to figure out is the number of data points before we can do anything. So there's 79. So in order to calculate the relative frequency, we take what we have here, which is 2 divided by the total, and that's going to give us 0.025, and I'm going to round 0.25. I'm going to round everything to the thousandths. That's 3 decimal places to the right of the 0. That's just for accuracy, usually either due to the hundredths, which is 2 decimal places, or to the thousandths. So I'm going to go ahead. I already did these to save time in advance. And 0.165. Remember that if you add up the relative frequency column, you should get 1. If you get a little over or a little under 1, that's fine, because sometimes there's some rounding. Depending on how you round will depend if you get 1. And a little above or below 1 is fine, and that's normal, and it's to be expected, and it is an acceptable answer. So now let's go over to the cumulative frequency. This first one is always going to be whatever the first relative frequency was. The next one down, we are going to add 0.025 plus the 0.051, and we're going to get 0.76. Let me see if I can just adjust this quickly. There we go. Okay, so then we'll just put the rest of these in. 405, we get 0.835, and then we get 1. So now we want to create the histogram off of this, and we are going to do this in our calculators. We're going to do edit. We're going to enter these values in. So 10, 11, 12, 13, 14. And the frequency is going to go in L2, so that's 2, 4, 26, 34, and 13. We want to do a histogram, so we're going to hit second, stat plot, enter. We want this stat plot on. We want it to show this. We're going to go down and go over to the histogram. Hit enter. Now we have to go adjust down here. Our X list is fine. Our frequency is L2. So second L2. And then next we need to adjust the window. The window is whatever you had it the last time you used the calculator, so you're always going to need to adjust that. And what we want to do for this, let's do 8, which is just a little below the 10. And then if you look at our max, why don't we do 16? We can do the scale of 1 for y. Let's go 0 to 36, scale of 1. Then we're going to hit graph. We should have a nice graph right here. So where it says create histogram, you could just sketch that or screenshot this right here. The next is skewness. So skewness, if we look at this, it looks like this data here, it's pulling out left. So we would say that this is skewed to the left. Now we want to create a box plot. What we are going to do is go back into second stat plot. I'm going to go into 1. We want it on. This time we want to go till we get to the box plot. Double check. We want X list in L1 and the frequency in L2. We'll hit graph. So here's our box plot. You could sketch that over here. The next is our 5-number summary. Now, if you recall, you can hit the trace button, and it's going to give you the 5-number summary, which the median is 13. Q3 in this case is also 13. The max is 14. Q1 is 12, and the minimum is 10. So we can also get this information if you hit stat, calculate, one variable stats, list 1, comma, list 2. So we can scroll down and you can get your 5-number summary right down here. Minimum Q1, median Q3, and max. Next, it's asking us to find the mean. So we have to decide if this is, oh, no, this is not. Well, we can decide now if it's a sample or a population. It's a sample, but our mean is 12.658. Just going to write this down here so we have this 12.658. Next, it's asking us what percent of times you checked your phone in an hour is more than 13. So here's 13. We want to know more than 13. So what percent of times, what's more than 13? It does not include 13. So more than 13 would be this last section here. We look at the relative frequency and we convert that into a percent. So it'd be 16.5% of the time someone checked their phone more than 13 times an hour. Next, it asks us to find the 60th percentile. So we're going to go up here knowing that we are going to use the cumulative relative frequency for this. So we're looking for the 60th percentile. So if you look here, the number of times you checked your phone in an hour, if it was 12, that goes up to 40.5% of the data. 60% is then in the 13. So 13, the number of times you check your phone in an hour, if it was 13, that is 83.5% to 40.5%. So 60th percent is in that 13. Next, we want to look at what is 2 standard deviations below the mean. So if you recall, in order to find this, then what we have to do is we use the value equals the mean minus, in this case, it's going to be minus 2s, 2 standard deviations, because it says it's below the mean. So 12.658 minus 2 times, okay, our standard deviation. So we need that from our calculator. Here is where we need to use the sample standard deviation because we realize that this is just a sample. So it's 0.904, and you get an answer of 10.85. So 10.85 is 2 standard deviations below the mean. The last problem for our review is this question. 2 second graders, Raina and June, from different teams wanted to find out who had the fastest time for the burlap sack race when compared to her team. So you'll notice that Raina and June, should say racer, both did the sack race at 52 seconds. Their team average was both 48 seconds, but their team standard deviations were different. So in order to do this, we want to first calculate value mean divided by we have to find the z-score, which is the value minus the mean divided by the standard deviation. Okay, so for Raina, it's going to be 52 minus 48 divided by 1.3, which I already did this calculation, 3.077. And then June is 52 minus 48 divided by 0.83. She was 4.819. Now, just to clarify, I do not want to do that. Let me just make some adjustments here. So I've got room to write this because I want you all to understand this. Okay, so what this means is that Raina is 3.077 standard deviations above her team's mean time. June is 4.819 standard deviations above her team's mean time. So if we think about this with a race, we want to be as quick as possible. Raina is only 3.077 standard deviations above her team's time, while June is further above 4.819. So in this case, Raina is the fastest, right? She has the fastest time. So that was our review. A couple of other notes I would like to say. Let me just scroll through homework and I can kind of go over from weeks 1 and 2, anything that I noticed. Let me get this out of the way. Here we go. Okay. Something that I noticed was that quantitative and qualitative were getting mixed up. Remember that qualitative is a word, so the answer is actually going to be a word, like a car, or in our example, it was a TV show. So you actually have to give a TV show. Quantitative would be a number answer. I already talked about the relative frequency and the cumulative relative frequency, that they're supposed to add up to 1, but sometimes it's not exactly 1 depending on how you round, and that's okay. In week 2, there was some confusion on outliers. Make sure that you understand that to find our outliers, what we do is we do 1.5 times the IQR, the interquartile range. So calculate 1.5 times that value, and then whatever it is less than that number and more than that number could possibly be outliers. The other big issue I saw was with standard deviation. Make sure you know what you're choosing. If it talks about a population, you need to use the population standard deviation. If it talks about a sample, you're using a sample standard deviation. And that's it for now. If you all have any questions about the exam 1, if you have any questions about project 1, please send me an email. I'm here to help and support you any way I can.